Okay, here we are. Question 3, Stats and Mechanics, Year 1, Chapter 11. Particle P is moving on a straight line at t equals 0. Right, t equals 0. The particle is at point A. Thank you. That's a terrible A. And is moving with a velocity of 8 meters a second. And so doing 8 meters a second. All right, towards a point B on the line where AB is 30 meters away. So we've got B over here and it's 30 meters. At time t seconds, where t is greater than 0, the acceleration of P is at 2 minus p2 seconds. Okay, so we've got acceleration is equal to 2 minus 2t. Okay, in the direction of AB, so in that direction. Thank you. Find an expression in terms of t for the displacement of P from A at time equals t. So displacement is going to be acceleration. So if we do acceleration in terms of t, if we could have velocity is equal to the integral of the acceleration, and then displacement is equal to the integral of velocity. So basically we need to do the integral on this twice. So as we do that, we're going to say v is equal to the integral of 2 minus 2t dt, and so that will equal 2t divided by 1 minus 2t squared divided by 2 plus c, and so v is equal to 2t minus t squared plus c. Then we can say the displacement is equal to the integral of 2t minus t squared plus c. Now then, should I work out what c is at that point? I do have a velocity and a time equals 0, so yes. Let's quickly sort that out. Because I know the velocity is 8 meters a second at t equals 0, I can very quickly put into this. Velocity is 8 equals 2 times 0 minus 0 squared plus c, and therefore 8 equals c. So I can change my velocity equation instead of plus c to be an 8. Now I can integrate in terms of t to find the displacement, and so that's going to equal 2t squared over 2 minus t cubed over 3 plus 8t plus c is equal to displacement. And so displacement is equal to t squared minus a third t cubed plus 8t plus c. Now then, find an expression in terms of t for the displacement of P from A at time t seconds. How can I deal with that plus c on that? Well, at time t, at t equals 0, s was also equal to 0 because we started a journey here. So our distance from A to B is that. We haven't been told the time it takes to get to B. So we can say that 0 is equal to 0 squared minus a third 0 cubed plus 8 lots of 0 plus c. So we can just drop that c because basically it is 0. So t squared minus a third t cubed plus 8t. Okay. Okay then, part B. Show that P does not reach B. Alright, well, we know that B is 30 meters away. So, how long will it take? How many seconds will it take for that to happen? So if we've got 30 equals t squared minus a third t cubed plus 8t, presumably this isn't going to have a positive solution or something like that, so that we can come out with it. We also know that the acceleration is going to make it get slower and start coming back in the other direction. So how many seconds until we've done 30 meters anyway? Well, let's put that equal to 0. 0 equals minus a third t cubed plus t squared, just rearranging it, 8t minus 30. How are we going to solve that? If this was a pure exam, we would be looking at dividing it, but your calculator does have a polynomial solver on it, which can do powers of 3. So minus 1 over 3, 1, 8, and minus 30 into there, and it tells us that t is equal to minus 5.1. Then I get a and also t is equal to 4.06 plus 1.04i, and then I also get t is equal to 4.06 minus 1.04i. So I'm getting the imaginary numbers and negative numbers for t, which shows that I'm never going to make 30 meters on it. Okay. We could also look at the idea of, as the acceleration comes through here, we do have a velocity, and we could look to see how many meters it is until the velocity comes down to 0. So if we take the velocity, which was this, 2t minus t squared plus 8, 2t minus, probably should have written that down better, minus t squared plus 8, minus t squared minus t squared plus 8 is equal to the velocity. Okay, how many seconds will it take for my velocity to get to 0, i.e. for it to stop? I know it started at 8. Okay, so if I just put that in and I take that minus t squared plus 2t plus 8, and again, look for the solve. If we do the discriminant b squared minus 4ac on that, that will be 2 squared minus 4 times minus 1 times 8. Okay, and that gives us what? 4 minus plus 4 times 8, 32, which gives us square root of 36. Well, no square root yet, but it would become the 6. Okay, and so we can do t is equal to minus b2 plus 6 over 2a, which is minus 2, and t is equal to minus 2 minus b. That should be a minus up there, shouldn't it? Minus 2 plus minus 6 over 2a minus 2. And so the t is equal to, what's that? That's 4 minus 2 on that one. That's minus 8, and that's 4. T equals 4 seconds. So after 4 seconds, we have managed to come to a velocity of 0. And after 4 seconds, using this one for distance, okay, s is equal to, so by the time it stops, okay, at 4 seconds, we're on 4 squared minus a third 4 cubed plus 8 times 4, okay, 16 minus 4 cubed, 64 divided by 3, 64 over 3, 64 over 3 plus 32, 16 plus 32 minus the 64 over there gives me 80 over 3, which is 26.6 meters, and it has stopped. Okay, so little sentence needed for that, saying the solve on the displacement expression gave only negative or imaginary answers for t when s was equal to 30, and the, is it a particle we're dealing with, and the particle p stops or has a velocity equal to 0 at p equals 4 and has only travelled 26.6 meters. Okay, that should do for that, I think. Right. Next bit, part C. Right then, part C. Find the value of t when p returns to a, giving your answer to 3 significant figures. Well, we know it has come back to there. I suppose what we need for that is to see when the displacement is 0. So when does this solve? So where is the displacement of 0? That will either be at t equals 0, and then also from there on in. So if we start with the displacement is equal to, what was it equal to again? T squared, let's do with minus a third t cubed plus t squared plus 8t. So minus a third t cubed something t squared plus 8t. What was it? Plus t plus. Okay. And we're setting that equal to 0 to find out when it returns. Okay. Plus t squared plus 8t. Divide it all through by t. So 0 equals a third t squared plus t minus, plus 8. And again, Let's solve the equation. So b squared minus 4ac, let's put in the square root for the discriminants, check that it's there. Okay, so we've got 1 squared minus 4 times minus a third times 8. And so we have 4 times 8. 4 times 8 divided by 3, 32 over 3 minus 32 over 3. It's not minus, it's plus. Plus 1, 35 over 3. Okay, and on a square root of that, it gives me 3.41. Okay, square root equals, was that 35 over 3? Square root of that. Yeah, okay, doing something weird there. 3.4156. Okay, so t is equal to minus b, so minus 1 plus 3.4156, all over 2a, all over minus 2/3, and t is equal to minus 1 minus 3.4156, all over minus 2/3. Banging that all into the calculator. T equals, right then, minus 1 divided by minus 2/3 is minus 3.623, and also t equals minus 1 minus 3.4156, all divided by minus 2/3, 6.623. We know it's 4 seconds until it stops, and then it starts coming back. So yeah, disregard that one, disregard that one. There's your answer, 6.62 seconds. Okay, did it want to? Oh, 3 significant figures. Okay, 6.62. Okay, find your value. Right, find the total distance travelled by p in the interval between the 2 instances when it passes through A. Okay, the total distance travelled. Okay, total distance, we've actually sorted this out because we did the solve earlier of the fact that it travelled a total of 26.66 meters to stop. So this particle between A and B has shot out to here to 26 2/3, okay, meters, and then it has come back 26 2/3 meters. So 26 2/3 times by 2 is 53 1/3 meters. Okay, because it has come across and come back like that. All right. Yeah, because as it's come out and it's been accelerating, it's accelerated to 0, and then it started traveling back the other way. And that's what we solved with this distance up here, in terms of we worked out when the velocity was going to be 0. Okay, and that gave us the 4 seconds. Here it is, velocity here, using the velocity equation we had, and we solved that for when the velocity had got to 0. which was 4 seconds, and after 4 seconds it had travelled 26.6 meters, and it starts accelerating still back in the same way, and it comes back to there. So done. I guess the only other way we could do that is if we put velocity equals 8, maybe, but I don't think so, and it might give us 2 solutions, but we know it's 53 seconds. Okay, 53 meters even, and a third. All right, good.